Hello everyone and welcome to the demo. Testing IBM Maximo Application Suite often requires teams to manually create test cases, develop automation scripts, configure environment-specific values, execute tests, and analyze results. This process can be time-consuming, repetitive, and difficult to scale. To address these challenges, we built an IBM Bob-powered test automation solution for IBM Maximo. By leveraging MCP servers, Maximo API schemas, product documentation, and a custom Bob mode, the solution can automatically generate test cases, create executable Python test scripts, validate them against a live Maximo environment, and produce detailed test reports from a simple business requirement. In this demo, we'll show how a Maximo requirement can be transformed into automated test cases, executable test scripts, and validated test results in just a few steps. This is the IBM Bob IDE, where we'll showcase the end-to-end test automation capability in action. This is a Maximo requirement provided in natural language, covering an asset management business process. Now let's go to Bob settings and view the custom mode created for this use case. Now let's go to the Maximo Python Test Writer custom mode. As you can see, this custom mode is specifically designed for IBM Maximo API testing. It can analyze test case documents, discover valid schema, and payload values from the live Maximo environment, generate secure and executable Python test scripts, execute them, and produce detailed pass-per-fail reports, all through a guided automated workflow. Now let's look at the MCP servers designed for this use case. This is the Maximo OpenAPI MCP server, which provides access to Maximo API endpoints, schemas, and object definitions. It enables IBM Bob to discover the correct APIs, identify required fields, and validate payloads before generating test scripts, ensuring the automation is accurate and aligned with the Maximo environment. Now let's look at the Maximo Docs MCP server. This MCP server provides access to IBM Maximo documentation and product knowledge, enabling IBM Bob to search relevant documentation, retrieve implementation guidance, and generate test cases based on documented Maximo behavior and best practices. By combining documentation insights from the Maximo Docs MCP server with schema and API metadata from the Maximo OpenAPI MCP server, IBM Bob can generate accurate and well-grounded test automation artifacts. Now, let's provide a prompt to IBM Bob to generate test cases based on the business requirement. As you can see, IBM Bob is now invoking the relevant tools from the MCP servers to gather API definitions, schema information, and product documentation required for test case generation. Now Bob is generating the test case document consisting of all the test cases for the requirement. As you can see, the test case document is now generated consisting of 20 test cases. And now let's view the test case document. This is the generated test case document. As you can see, IBM Bob has automatically created a comprehensive test suite from the business requirement, covering asset registration, classification, parent-child hierarchy management, lifecycle status changes, validation scenarios, and security checks. The document includes detailed test cases with API endpoints, request payloads, test steps, expected results, pass criteria, execution checklists, and environment requirements, providing complete coverage of the business process. This test case document will now serve as the foundation for automated Python test script generation. Let's now generate a test script for the first test case. This test case validates the creation of a new asset using the minimum required fields and verifies that the asset is successfully created in Maximo with the expected default values. Now let's provide a prompt to IBM Bob in Maximo Python test writer mode to generate a test script for the first test case. This prompt instructs IBM Bob to create an automation script for TC asset 001, which validates asset creation using the minimum required fields and verifies that the asset is successfully created with the expected response. Using the test case, API schemas, and documentation retrieved from the MCP servers, Bob will automatically create a production-ready Python test script with the required validations, assertions, and reporting capabilities. As you can see, Bob has now started generating the Python test script. As you can see, the test script is now generated. Once the test script is generated, IBM Bob automatically prompts for approval before executing and validating the script against the Maximo environment. On approval, it executes the test script and validates the result. As you can see, the initial execution identified a few issues in the generated test script. Bob automatically analyzes the errors, identifies the root cause, and updates the script accordingly. It then revalidates the corrected script to ensure it executes successfully and meets the expected test outcomes. Once all the required changes have been applied, Bob automatically reruns the test script to validate the fixes and ensure the test case executes successfully. As you can see, the test script executed successfully, with all validations and test steps passing successfully. As you can see, Bob is now documenting the test results in a structured format. As you can see, the test script and test results are now generated. Once the result documentation is complete, Bob presents a summary of the entire execution process. Now this is the Python test script generated by Bob for TC asset 001. The script securely loads credentials from the env file and uses reusable API helper functions for Maximo interactions. Before execution, Bob discovers valid site ID and org ID values from the live environment and performs a cleanup check to ensure a clean test run. It then creates the asset, validates the response, retrieves the created record, and verifies key fields such as asset number, site ID, and org ID. Finally, the script records each validation step, generates a pass, fail summary, and exits successfully when all checks pass. As you can see, the test executed successfully with 8 out of 8 validation steps passing, resulting in an overall pass status. During execution, IBM Bob discovered the valid site ID and org ID values from the live Maximo environment, generated the test payload, and successfully created a new asset. Most importantly, the asset test asset 001 was successfully created and validated in the live Maximo environment. Bob then verified the asset number, site ID, organization ID, status, and other key fields to confirm that the record was created correctly. Finally, IBM Bob generated this detailed test report, providing complete traceability of the execution steps, validation results, created asset details, and overall test outcome. Now let's verify whether the test artifact, test asset 001, was successfully created in the live Maximo environment. As you can see, the asset has been created successfully and is available in Maximo. We can also review the asset details, including the asset number, description, site ID, organization ID, status, and other metadata that were validated during the automated test execution. This confirms that the generated test script executed successfully and that the asset was created and validated end-to-end against the live Maximo environment. In just a few minutes, we went from a natural language Maximo requirement to a fully validated test outcome. IBM Bob automatically generated test cases, created a production-ready Python test script, discovered live environment values, executed the test, resolved issues, and generated a detailed test report. Most importantly, the asset was successfully created and validated in the live Maximo environment, proving that the generated automation works against real enterprise systems. This demonstrates how IBM Bob can dramatically accelerate the journey from requirements to validated test results, reducing manual effort, improving accuracy, and enabling faster delivery of high-quality applications. Thank you for watching.